Right, today is statistics. Statistics. This is a new GCSE. I think it was only introduced in the last 2 years because there's not many past papers. There's literally just 2020 and 2019. So this is a new course. And I'm surprised it took this long because statistics is so important a subject. Like, why wouldn't they have it decades ago? Like, um, I mean, they have it in maths, but I don't know. I think it deserves its own course. Okay, so let's see. Statistics. I'm predicting a 9 for this. Like, I should get a 9. It's GCSE level. I don't know what the course, what the syllabus is, but how hard could it be? We'll find out. Um, uh, okay. So, let's fill in some stuff. Okay, so we've got we need pencil. There we go. All right, what was it? It was 80085. Candidate number 2. No particular reason. Has the size changed? No, it's the same as before. I don't know. Feels a bit. One hour 45 is an awkward amount, but fine. I'll probably finish earlier. Oh, calculator. All right, I'll open Google just in case I will need a calculator. So, okay, there we go. All right then. I guess I'm ready. So, wait, put this away. And begin. All right, the table shows the index numbers for the cost of an item in different years. Circle the base year. What? Base year? What the heck is the base year? I have no idea what the base year is. All right, what could it be? It can't. I mean, it wouldn't be the median. It wouldn't be the mean. Could it be the year which has the average? But then you wouldn't be able to calculate that easily. 90, 95, 100, 115. So what's the average? Somewhere between 95 and 100. I don't know. What is the base year? I'm stuck already. I'll just go with the modal. Let's go with that. Base? Okay. Here are some summary measures for distribution. Second decile. Largest value. Okay, the difference between the second and 8th deciles is 30% less than the range. Circle the value of the 8th decile. Okay, so the range is 150. So what's 30% less than the range? That would be, hello MC2M. I would say base year as in a point of reference, where it would be Yeah, I was thinking something along those lines, but I can't see someone having to calculate that for only 1 mark. So I feel like it's got to be something. Wait, but I don't understand how you get 100 from that. Either way, surely you want like 97.5 or something. No, I don't know. Oh no, wait, not 97.5. I didn't notice there was a gap between 100 and 115. I'll go with what I put anyway. Right, 150. So 30%. Okay, so 105 is when you subtract is 70% of 150. Is that right? Yeah. So difference between the second and eighth deciles. So it will be 140. All right. The geometric mean of 3 and x is 6. What's geometric mean again? It's 3 times x square rooted equals 6. So 3x equals 36. So x equals 12. Circle the letter of the scatter diagram for which the Pearson's product moment correlation coefficient is -1. I don't remember much about Pearson's, but I'm pretty sure it's D. Also, I think they renamed it to Pearson's. It used, in my day, it was called Spearman's rank? No, that's probably something different. No, Pearson's. Yeah, we did Pearson's. Yeah. Yeah, it's a measure of correlation. So C would be like -0.85 or something like that. Marcus is planning a driver safety course. He wants to give the people attending the course a questionnaire to complete. Marcus wants to know how far each person usually drives in a week. Write a closed question that Marcus could ask to find out this information. Include a response section. How far do you drive in a week? Should we say on average? Is that what they're getting at? Or should we say last week? Yeah. Because that would be more of an open question, as is how far did you drive last? But last week might be special. Like we might have been holding the UK Jubilee last week. In which case people were traveling from all over the UK to see the Queen for reasons. Whatever. Let's say 0 to... I don't drive. I have no idea what is a average drive in a week. Let's say 10 miles? 10 kilometers? It's UK, so we use kilometers. 10 to 20? 20 plus? I have no idea whether that's... Okay. Alright, Marcus also wants to know whether people regularly drive faster than the speed limit. plans to collect the information using this method. He asks each... Oh, they're playing a dice game. It's like that game where you put in the red card or the black card. Oh, that's clever. Okay, I see. So you get what you want as long as you get enough people playing this game. But you never know if, for an individual whether they told the truth or not. Okay, fine. Oh, well, we've basically answered this question. For each individual person, Marcus can't know with high probability that they committed one T, two T's? Committed two T's. A crime. That's a good method, but I've never seen anyone do that in a survey before. Marcus collects data from 100 people using this method. 60 people give the answer yes. No, Marcus. You came up with a smart plan and then you did the maths wrong. So it was about half of the people would roll odd. These should be discarded %. 5 faster. No, not. Wait. It would be 10% out of the remaining 50%. So it's hang on. Yeah, 10 people out of the remaining 50 people. 10 out of 50 equals 20%. Drive faster. On average. Let's say on average, just in case, I don't know what the mark scheme will say. A YouGov survey was carried out with nearly 2,000 British working adults who have an 8-hour working day. Okay. They were asked which period of 8 hours they would prefer to work. Okay. Show that about 2/3 of adults questioned wanted to work earlier than the traditional 9 a.m. to 5 p.m. working hours. So we go from here to here. So it's 2 plus 1 plus 5 plus 2 plus 10 plus 8 plus 25 plus 13. Equals 28, 53, 66. Amber. None of the adults questioned wanted to start work at 11:30 a.m. None of the adults questioned wanted to start work at 11:30 a.m. 11:30. So there was 0 rounded to the nearest whole number. So it could have been 0.5, or let's say 0.499 or whatever, and that would have been rounded down to 0. So 0.5% of 2000 equals 1. So if there was one person would represent 1 in 2000 equals 0.5%, which would round to 1. Therefore, must be 0. She's correct. Hang on. 1% of 2000 is 20. Yes, okay, I've done a stupid mistake here. So 0.5% is 10. Okay, so it's... So... Let's erase this. All right. 10 persons would round to 1%. 9 0%. Therefore, don't know. Yeah. Give one reason why these results would not apply to all British working adults. Wait, what? Because it excludes those who are not already working, is it at least 8 hours or precisely 8 hours? Okay. Okay. All right, we've got 200 students, 200 parents, young children, and 200 retired people. What was the first thing they did on their mobile phones that day? Okay. Students, mainly social media, but quite a bit of gaming. Parents, mainly social media, then news and other. Retired, mainly social media and news. One of the people is chosen at random. Work out the probability that this person goes on social media first that day. Okay, so it's 1 in 3 times um 1, 2, 4 out of 200 plus 1 in 3 times 120 out of 200 plus 1 in 3 times hang on, am I doing this right? No, you don't need to do this. You just say it's 124 plus 120 plus 88 out of 600. Well, no, that was the same thing. Okay, whatever. You don't need to do it like that. All right. 3. Hang on. Yeah, that's fine. Okay, so that's 332 out of 600. They want it as a percentage. 3, okay. 332 out of 600. $55.3. I think fraction would be fine anyway. Work out the probability that this person does not go gaming first that day. Okay, so it's 1 minus 52 plus 8 plus 11 out of 600 equals 1 minus 71 out of 600. Okay. Equals 529. I think they want the fraction. They want the exact probability. I'll just leave it as a fraction then. One of the people who went on gaming first that day is chosen at random. What is the probability that this person is retired? So it would be 11 out of this column, basically. So it'd be 11. It's Bayes' rule, but we don't have to write it out explicitly. 11 out of that number again, 52 plus 8 plus 11. equals 11 out of 71. Look at the probability that 2 of the 200 retired people chosen at random both went on news first that day. Okay. Okay, so let's just work out the probability of 1. 1 of the 200 retired people going on news first that day. So we got 200 retired people. So it's 67 out of 200. 67 out of 200. And the probability of the second person, so it's without replacement, so that times 66 out of 199. Okay, 67 out of 200 times 66 out of 199. 67 out of 200 times 66 out of 199. 11.1. 3 decimal places. 11 point. No. Oh, no, not a percentage. Equals 0.111. Does that seem about right? About a tenth? Yeah, I suppose. I mean, it's about a third. A third multiplied by a third is about a ninth, and 0.111 is a ninth, so yeah, okay. Joe looks at the data in the table and makes 2 statements below. Is each statement correct? Take a reason for each decision. Most of these 600 people went on social media first that day. Most. What is meant by most? More than 50%? This is ambiguous, isn't it? Or does that mean it's the social media, amongst the activities, social media was the highest? Well, anyway, how many went on social media? We did this before. 332 out of 600, which is more than 50%. So either way, it's most. Three, three, two. Did social media, which is more than 50%. first that day. Yes, that day. That's what the data shows. All right. Most of these 200 retired people go on social media first every day. No idea. We don't know what they do every other day. Don't know what they do on other days. Simple as that. I mean, yeah. A deadly disease currently has no treatment. A researcher develops a drug which she believes will treat the disease. She suggests a statistical experiment to test her drug. Infect 6 people chosen at random with the disease. Okay. I mean, they do studies like that. That's fine. People volunteer. They did that for COVID, didn't they? People actually volunteered to be infected with COVID. Give the drug to all 6 people. Record whether each person recovers or not. So there's no control study. Okay, let's see. Okay. No control study. Infected infected without drug. Problem 2, 6 is a, by any measure, that's too small a sample size. The researcher carries out a more suitable experiment. She writes an article for a magazine to highlight her results. She gives the name of each patient in the experiment and records how they responded to the drug. The magazine editor asks the researcher to rewrite the article because you put their name on the bloody magazine. Patient data should be confidential. All right. In an experiment, Paolo throws 3 fair coins. He repeats the experiment 120 times. How many times should he expect to throw 3 heads? So, probability of 3 heads equals half cubed equals 1 in 8. So we want 120 over 8, which is 15. A geyser is a spring which erupts from time to time and shoots a column of hot water into the air. 80 eruptions of a geyser. Okay. Oh no, frequency polygon. Okay. It's not a histogram. Huh, wait, what's a frequency polygon? Frequency polygon. This seems like something that's just not nearly as good as a histogram. It's not going to be... my first instinct was just to draw a bar chart, but that's... I think we'll probably have to take the midpoint of each range, so 40 to 80, frequency 1. So, wait, we got 40, 80, So put a dot here. Or a... okay. But... I mean, that would be a polygon, but it's not very useful, is it? You're not taking into account the width of the intervals. But that's why you want a histogram, source of frequency polygon. Oh, they're fixed. The intervals are fixed width. Okay, that's fine then. So we can just take the midpoint, I guess. Okay, so 80 to 120, 19. All right, so 80 to 120 is 19. 120 to 160. Okay, fine. So the midpoint, 140, 17. All right, so 140. 17. 181. 220, 17. 260, 20. 305. And then I assume you just join them up. This is gonna look horrible. Just pretend I used a ruler. Should there not be a point between 119? Oh crap. No, I did that one. 119. No, it's fine. Okay. Okay. I'll be forgiving here because you would have done it with a ruler and everything. So. Calculate an estimate of... Okay, calculate an estimate of the mean duration of an eruption. Sum of frequency... 2 hilltops. Yeah, it's like a what's it called? Binormal distribution, bimodal. Okay, so FT. Is it just, hang on, sum of, what exactly is sum of FT? Is it just going to be frequency times the midpoint? Probably. So it'll be sum of FT divided by sum of F. 14960 divided by 80. 14960 divided by 80. 187. So that's 50s, 78. So it's about here. Yeah. But the problem is it's by. Is bimodal the word? I think it's. I mean, it's binormal if it's actually Gaussian, but this is not Gaussian. This is just, I think, bimodal. The data appears to be bimodal, i.e., what exactly do we mean by that? Two distinct peaks? Why the, no, what's the question exactly? The mean is not a typical value for this set of data. What do they mean by typical value? It's not a common value, but that's also like saying, you know, it's not common to find a person with 1.9 arms. That's probably what they're asking. Okay, so the mean falls away from these. I don't know how to express what I'm thinking. Frequent values. Make this more explicit. 187 is not frequent when interpolating the population pyramid. Shows the ages of people who moved house in England and Wales in 2016. One bar has not been drawn. 350,000 females aged under 20 years moved house in 2016. Okay, so what have we got here? So we've got 0 to 9. Females is on the right. Okay, so females is on the right. So that's 160,000. So this remaining one should be 350k to grade 160. Okay. 190k. So okay, that's a mess. Calculate the percentage of all people who moved who were aged 20 to 29. 20 to 29. All right, so we got on this side, we've got 400k, and this side, we've got 540k. So we got 400 plus 540 over all people. So it would be 1,400 plus 1,550. So we got 950 out of 940 out of 950. 940 out of 950. Forty 48.2%. It's just one reason why such a large proportion of people moving are aged 20 to 29. Because that's the age when you move, isn't it? That's like when you're finally an adult. But when they say moving house, what exactly do they mean? Are they counting people moving out of their parents' house? Probably. Yeah, because that's moving a house. Sure. So people of that age are moving out of parents' houses. I mean, if they can afford to in this day and age. Good luck with that. Probably easier to move to Thailand. Some of us did. The table shows some information about people with hearing loss in the UK. Mike says the risk of hearing loss for people aged 60 years and over is about 10 times greater than the risk for people aged under 60 years. Okay. What does it mean by risk? Probability. Okay. So probability hear loss for 60 plus equals so we don't care about the U, but oh I see. Okay, fine. Equals 8290000 out of 5590000. Okay, let's just cancel out those zeros. 829 over 1559. 829. $53.2. probability of 8 loss for 60 minus equals 275,000 out of 50,450,000. So it's 275 out of 5045. 275 divided by 5045. 5.45%. It's quite a lot of hearing loss. Actually, well, no, that's okay. How do you define hearing loss? Because if you lose your hearing a little bit, that probably qualifies as hearing loss, doesn't it? In which case, that almost seems low. Like everyone who's over 60 eventually loses some of their hearing. It's just a question of how much. Yeah, you have to be a bit more clear on how you define hearing loss. For all I know, maybe there is a clear definition. So Mike's right. So Mike is correct. 53% is about 10 times 5.45%. Yeah, I don't see any catch there. Alright, about 1 in 9 people, at a certain age you can stop listening, and later in life you call it hear loss. I see. Yeah, maybe that's it. But 1 in 9 people in the UK aged over 60 years have sight loss. Only 1 in 9? Again, how much sight loss are we talking? It must be near 100%, seriously. Everyone who is over 40 eventually gets some near vision loss for like reading and stuff. Unless you're incredibly lucky. So 60. I mean, I had sight loss when I was like a teenager. Then I got laser surgery. Calculate an estimate of the number of people in the UK aged over 60 years who have sight loss. Okay. Over 60 in the UK is 1559 and then 4 zeros. 1559, 1, 2, 4 multiplied by 1 in 9 equals 1559, 1, 2, 4, 559, 173, 2222. 173, 2222. That's so low, that can't be right. It must be more than 1 in 9. Alright. Machine fills bottles with orange juice. The amount of orange juice in a bottle follows a normal distribution. Oh, so they do cover normal distributions in GCSE. Good. With a mean of 500 milliliters and a standard deviation of 10 milliliters. Approximately what percentage of bottles contain more than... Oh, I forget this now. What is it? it's I think it's like, okay, so it's okay, you got normal, one standard deviation. I think it's like 66% fall within one standard deviation. But that's two-tailed. They're saying, so that would leave, so that leave 34 outside. But then you need to halve that because they're looking for this upper tail. So about 17. So I'll just go with 16%. But then I don't know if that 66% is right, but that feels right. Yeah, because it's not going to be more than, it's not going to be 32 or 68 or 84, because that would mean the that would just mean very few fall into within one standard deviation of the mean. Okay. The manufacturer would like almost all bottles to contain between 488 milliliters and 512 milliliters of orange juice. Sophie says this could be achieved by reducing the standard deviation to 4 milliliters. Comment on Sophie's claim. Okay. So okay. So this time we've got three standard deviations. This range encompasses three STDs. You do not want to get three STDs from the mean. So what was it? Oh man, it's a long time since I've done this. 66%, 95%, 99.5%. I'm gonna go with that. So about 99.5%. So I would say Sophie's claim is sound. It's really up to the manufacturer to specify what they mean by almost all. That's pretty vague. Because 99.5% is pretty good, I guess. At least in this industry. It might not be good for like healthcare, but it's good for food production. Okay. Okay. UK imports of clothing in millions from the rest of the world between 2015 quarter 3 and 2017 quarter 4. Some of the 4-point moving averages are also shown. Okay. Complete the table by calculating the last moving average. So the moving average is these four, right? So this one will be these four. So it would be 4750 plus 4630 plus 5450 plus 5190. 4 equals. Alright, we got 4750, 4630. 4750 plus 4630 plus 5450, 5190, divided by 4, 5005. Okay. Comment on the trend in the data. There seems to be an increase. Steady increase. Pretty steady. It's about 40 to 60 each time. 40 to 70. Yeah, I would say there appears to be a steady increase over the years. The diagram shows the value of UK clothing imports in each time period. A trend line has also been drawn. Let's specify on a per year basis, because clearly it is following a pattern. But if we consider on a per year basis, on a year as one fixed time period, yeah. All right. Make one comment about the seasonal variation shown in the data. Q2 is... What's Q1? Winter? So we peak at Q3. What is it? What were we selling? Clothing. Wouldn't people buy more clothing? Well, oh, it's cost of clothing. Okay. Expecting me to know which seasons map to which Qs. I don't know. I don't care much for this. I'm gonna guess that Q1 is spring. I feel like the year, even though there's more of the winter in the beginning of the year than at the end of the year, I feel like in the business world they like to pretend everything begins in the spring. I could be wrong. And ends in the winter, because then you've got Christmas and New Year. So, but there is a peak at Q3, which doesn't make sense. Why Q3? So are we saying Q3 is the autumn? I mean, it's either the autumn or the summer? I'm gonna say autumn, but That doesn't make any sense. Yeah, why would it be autumn? All right, based on the data, I'm going to say that I'm going to say summer is Q3 because summer is an interesting time for people to be buying clothes, I guess. I don't know. So I'm going to guess clothing imports appear to peak in summer Q3 and decrease over the remaining seasons. I guess because people go out the house more. Do I need to explain why? Probably not. Just in case we do need to, people going out more. I mean, it's England we're talking about, so you get like 5 days of sun in the summer. So those are the 5 days you're gonna put your fancy clothes on. So, all right. The seasonal variations for Q1 are shown in the table. (2016 Q1 minus 40). (2017 Q1 minus 150). Okay. Okay, so the mean is just what? Those two added together divided by 2? We've only got 2 pieces of data. Okay, that's fine. Mean equals minus 40 minus 150 over 2 equals minus 192 equals minus 95. Hang on, I don't understand this. Minus 40. Minus 40 from what? So we're talking about Q1. Previous Q1? Right, between 2016 to 2017. It's an increase of 150. Why is it minus? So they're referring to what happened from 2015, even though we don't have the data. Okay, so from 2016 to 17, we add 150. For some reason, that comes a minus in this table. I don't understand that. But if we're following this pattern, then we add 95. So 95 plus 4750 equals 4845. Okay. 4845. I don't know. Write down one assumption that you made in making your prediction in part DI. I assume the variation seasonal is roughly constant year to year. All right, we got another 35 minutes left. I think we got enough time. In this question, you will need to use standardized score equals score minus mean over standard deviation. Okay. Swimmers in a competition swim 2 races. Swimmers use breaststroke in race 1 and backstroke in race 2. The mean and standard deviation of the times in each race are shown on the table. Okay. Rachel's time in race 1 was 48.7 seconds. Standardized score, okay, fine. So, score in race 1 equals. Okay, so 45.5. No. 48.7 minus 45.5 divided by 2.4 equals 48.7 minus 45.5. One and a third, exactly. Okay. .33. So that's bringing it basically to the standard normal distribution with a mean of 1 and a standard deviation of with a mean of 0 and a standard deviation of 1. Yes, and she was more than 1 standard deviation. That makes sense. Okay. So stand score in race 2 equals x minus 41.7 over 1.8. But we know that equals 1.33. So x equals 1.8 times 1.33 plus 41.7. 1.8. That's interesting. When you multiply 1.1.8, you get 2.4. That's right. Plus 41.7, 44.1, 44.1. Does that sound about right? It's about just over a standard deviation. Yeah, maybe. Kim and Priya also swim in the competition. Their times in each race are shown in the table below. Okay, so race 1. Kim. Stand equals 43.7 minus 45.5 over 2.4 equals 43.7 minus 45.5. We'll just use the template I had before. Okay, 2.7 minus 45.5 minus 0.75. Okay, yeah, that sounds about right. Minus 0.75 minus 0.75. Priya 44.3 minus 45.5 over 2.4 equals, okay, this is 44.3 minus 0.5 minus 0.5 and then 2. Okay, so we got 40.5 minus 41.7 divided by, what was it, 1.8? Yeah. 40.5 minus 41.7. $53, well, 0.54. All right, and Priya 40.3 minus 41.7 over 1.8 equals 0.537. Okay, so start with Kim. So she did better in race 1. No, sorry. They both did better in race 2 by far. Because it's positive, not negative. So they both exceeded. Hang on. Am I ignoring the negative numbers here? Oh crap. Oh my god. That number doesn't even make sense. Hang on. 40. 40.3 minus 40. Okay, I have to redo these numbers. They should be negative. And nothing like what I have here. Minus 0.778. Okay. Minus. So that last one. Minus 0.778. And the second to last one was 40.5. I had a divide instead of a minus. 0.667. Sorry, minus. Minus 0.667. There we go. All right. Hey, Kim. So, race 2. Priya. Race 1. Because the standardized scores are higher for these races. Does that make sense? Race 2, race 1. So Kim did better in race 2. Priya did better in race 1. Yeah, sure. Okay. In a golf tournament, players take part in several rounds of golf. Players try to complete the course taking as few golf strokes as possible. Justin wants to compare the number of strokes taken by the players in the first 2 rounds of the tournament. Collects data of the top 50 players. Justin's hypothesis is in what? I don't even need to read that. I just saw the question mark and it's like a hypothesis should be a claim statement, not a question. Okay. Cumulative frequency step polygon. Fine. To show the results. So that's a step polygon. That's different from what I did before, which was a polygon something or other. Explain why a cumulative frequency step polygon is an appropriate graph for the data. Because it just is. It's just what you do. I don't know. Because it gives you a sense for the skewness of the data, I guess. That's why you... Great, so this is this is round 1. I don't know what they're getting at here. Gives a sense of the skewness of the data. Work out the percentage of players who took 72 strokes or fewer for round 1. Alright, so we're here, 72 fewer. So it's 10. It's cumulative. No. No. It's where this bar reaches. So 16. It's the upper end, because the bar at the end reaches 50. There's 50 people. 16. I'm not really sure about my answer for 1B. Can't think of something better though. Alright, complete this table summarizing the number of strokes taken by players in round 1. Median is 74. Yeah. Sure. Lower quartile 72. Upper quartile, so 75% mark. So 37.5 people. Where is that roughly? So that's about there. So I was 76. Do I need to put some... The lowest number of strokes taken at round 1 is 65. Show by calculation that this value is an outlier. What calculation? How do you define something to be an outlier? Outlier is like a subjective. Okay, 3 marks? Okay, so we find the percentile. 65. What was it? Yeah, 65. That is 1. So 65 is 1. 1 out of 50 equals 2%. So how is this 3 marks? This is the 2 percentile. Isn't that all you need to say? Or what more? Do you need to use the median? No, because 2 percentile in itself, I mean, it kind of tells you it's an outlier, doesn't it? Which falls way below the lower quartile. We don't need to quantify how much it falls because we don't have any standard deviation or anything. I don't. Ah, you know what? I've thought of a better reason than this. Allows us to estimate percentile values. All right, I don't know how you're supposed to get 3 marks there. Summary of the number of strokes taken by the same players in round 2. Cool. So we need to fill this table out. Oh no, we have to draw this. Okay. We've got 15 minutes left. Right, so we want to start at 69. And we... Oh, I see. Okay. So 69 and we reach 4. Right. So... Okay. And then... 79. 70. 71, 16. $72, 27. $73, 35. $74, 41. $75, 44. $76, 48, and then 50. Wait, yeah, 77, 50. Oh, okay. Draw separate box plots on the grid below for the number of strokes. Box plots. So that's like box and whiskers. Do they include the whiskers? Okay. So, okay, how's this work again? So round 1 was 72, 74, 76. 72. Okay, so we got 72, 74, 76. So you got the box. You got the whiskers. So the lowest value was 65. The highest value is 78. 65. Ugh. 78. All right. Round 2. Mark clearly the outlier for round 1. Well, here. How do they want us to mark it? I don't know. Okay, so he. Oh no. Okay, fine. So. That's the end of the paper. Okay. So we've got some time. So the median is. So we've got 25. So that is 72. So the median is 72. Lower quartile. So that'll be 12.5. This is 71. And the upper quartile, let's say 12.5. And 37.5. Which is corresponds to 74. Okay, 71 and 74. And then we've got 69 and 69 to 77. 69 to 77. So there was an overall, there was a So if we discard 64, what happens? So 65. We end up starting at 69. I think that's what they want us to do. So really, if we're discarding the outlier, and just put a cross there, the outlier. All right, that looks better. That makes it pretty clear then. Okay. There is a clear reduction overall in strokes in round 2. You know what? The percentile. So let's go back. We have not much time left. This is the wrong answer that I've given here. The percentile doesn't matter. No. Of course, that one person is going to be the 2%. That doesn't mean he's an outlier. Each individual is counts for 2%. What calculation do we do then? let's take the interquartile range. That's the only measure I can think of that we normally use. All right. Interquartile range equals 4. Let's just spell this out. 76 minus 72 is 4. 65 falls more than... Okay, I'm just bullshitting at this point. More than 1 in QR below. Do we care about the... Do we care about how low it is below the quartile or the median? Below the lower quartile. Why don't we just talk about both? And so below the median, it's two IQRs below median. So statistically unlikely. Whatever. That's better than talking about the percentile. That was meaningless, what I said before. There was a clear reduction overall in strokes in round 2. Everything has decreased apart from the lower quartile, upper quartile, median, and have all, and highest val have all decreased. The IQR and range have both decreased, which implies more consistent, less spread. Write down a factor that could explain the difference between number of strokes in 2 rounds. The players learned from their experience in round 1. But also, it was on the same course, wasn't it? It was the same 50 people, wasn't it? Yeah, same players. And it must be the same course, otherwise they're not comparable. So the players learn from next season and are now familiar with the course. They actually know where the hole is and everything. And what's difficult about it and so on. All right, 2 minutes left, so I'll just finish there then. I didn't miss any questions out today. It's fine. All right then. All right, let's get this. Of course I got this wrong. All right, so the answer is 2017. That does make more sense. I mean, looking at that, my gut feeling is whatever base means, 2017 is the base, but I can't think of any simple measure to go by for that. It just... don't know. All right, let me write this down. Forgot to give myself a pen. 1 second. Oh, I did give myself a pen. All right, 1 mark lost. The very first mark. I don't know what that means, base year. Shall I look it up now? Base... Well, what would you even search for? Okay, UK GCSE, because it might be very specific to GCSE. What is base? Well, it's not going to be base year. It's going to be base... Oh, chain base index numbers. Base index means the arithmetic average of the final... What? The arithmetic average of the final version of the indexes published for them. Is it literally just the average? Wait, what is the average of these numbers? So it would be... Oh, it is 100. It's the average. So the base year is the year that has the average. Why didn't I calculate the average? I kept briefly mentioning the average, but saying, nah, it can't be that. But still, that doesn't make sense. There wouldn't always be a year that has the average. So how do you decide which year to pick? What did that web page say? Because it's an incredible coincidence that there happens to be a year with the average. I can't Google this. I can't find this just by Googling. I don't know. I don't know the answer to that. And I'm not even that interested, to be honest. That is not a standard term, I don't think, in real life statistics. Maybe it is. I've never seen it. All right. 140. 12. D. Oh, they do want us to say how far do you drive on average, not how far did you drive last week. Okay, so what do I get for this? Clearly, my response options are good according to these criteria. 0 to 10, 10 to 20, 20. Who's the time period? So I satisfied 1, 2, and 3. Yeah, but I didn't ask how far a person usually drives. I just asked last week, and I even mentioned earlier that what I said is actually problematic in its own way. Yeah, I should have gone with my first question. Okay, let's have a look at the mark scheme. I reckon I would lose 1 mark for not satisfying the first bit, a question regarding how far a person usually drives. But I got the others, so it doesn't really say what to do in this situation, so I think I shouldn't lose more than 1 mark really, because clearly my response options are good. I think that's fair. Okay. Why does Marcus use this method? Because was it, did I get this mark? I said uses this method so that he doesn't know what they said. But say that he doesn't know that they committed a crime. It's not exactly how they worded it. They've said it is a sensitive topic, may not want to say, to ensure he gets truthful responses, to improve the response rate to the question. I didn't actually say any of those things, but my thing still makes sense. But I'm being a bit too literal here. I'm not giving the overall reason why. This. I mean, well, these are. Alright, let's have a look down here. No, that's B2. It doesn't say anything. See, if it said anything which makes sense, I would have given myself the mark, but it actually says these 3 things. The closest thing is it's a sensitive topic. But I didn't actually say that. But I did say that they committed a crime. I think I got that first sentence there. It is a sensitive topic, may not want to say. That's kind of what I'm saying, but in a very different set of words. But It's these one marker questions that are so confusing to mark. I think I got that mark. I'm giving myself that mark, but I don't know for sure what I would have got. But I think it's just a rewording of their first point. All right, B2. So let's see. Yeah. Yeah. I got those. Oh, it's just one mark. It's just any of those three things. I said all three things. Okay. All right. $66. Cannot tell. B. Due to rounding. Yeah, I was just very clear on. Yeah. Give one reason why these results will not apply to all British working adults. Not all. Yeah, that's what I said, basically. Okay, 7AI, 55.3. Yeah. What color probability does not go on gaming first? 529 out of 600. Yeah. 11 out of 71. 0.111. Yep. All right, so now 7D, we've said yes and then can't tell. Yes. Yeah. And cannot tell. Yeah, that's what I said. Oh, yeah, that's the 2 marks. So you can also tick no. Oh my god. No is actually the correct answer. I mean, I got it. They let you have the answer for cannot tell, but that's quite smart actually. The answer is actually no, because if that day, hang on, so it's fewer than 188. Yeah, so the actual fully correct answer is no, because that day that they did the study, it wasn't most. Therefore, it can't be every day, because it wasn't that day. All right, so I got the marks. But I don't deserve the marks. Like, they should have been strict on that. The answer is no. That's a tricky one. Okay, 8A. No control group. Yep. 6 is a small sample size, is what I said. It has to be voluntary. Well, They don't have one for... Oh, they do. I didn't look up. Ah, okay. 6 is not enough. Yeah, yeah, good, we're good. I was worried. Like, no way would 6 be considered a good sample size for any study, really. Ethics cannot infect randomly chosen people with a deadly disease. Well, I thought, okay, it wasn't stated, but I thought they meant chosen at random from a willing population, a willing sample, bigger sample that are willing or have consented to this, but they didn't actually say that, so I shouldn't have assumed that. But I mean, it's just such common sense that I didn't think to question that. But yeah, you don't want to just infect random people. Patient data should be confidential. Yeah. 15. Nice. It looks like a geyser. Right, 187. Yep. Alright, I'm doing well. I only lost 2 marks so far. Bimodal. Yes, I said bimodal. That's all you need to say. Okay, 190k. Yeah. $48.2. No. Hang on. What did I do wrong here? How did I get 48.2? No, it should be. Oh my god, it's 2,950 on the bottom, not 1,950. Okay, so let's see. I got the first mark because I said 400 or 540. Yeah. I didn't get that second mark. And A1, I don't think you're allowed to use... Yeah, no. So I only got 1 mark for that, I think. I don't think you could just use the wrong calculation to get... The A marks have to be as on the scheme, mark scheme. I don't think you're allowed to carry forward marks like that. So I got 1 mark for the for... You get marks up until the point it goes wrong, basically. Well, no, I mean, M1 dep means if you got M1 wrong, the first one, then you would still get M1 dep. But this does not say A1 dep. Yeah, so I only got 1 mark. Damn, that's 2 marks there. Just for putting a 1 instead of a 2. (11B2). People of that age are moving out of parents' homes. Yep. So what have we got here? Yeah. So I got those 2 values. Yeah. And then... Yeah. I got that. 1732222. Yep. Okay, 16%. Yep. Yeah, so it's 66% fall within the two-tailed distance. Sophie is correct. I mean, I said... Hang on. So... It's 2 marks. B1 for 1 calculation. I didn't do any calculations. Oh, no. It's B1 for calculation or a link made between 3 SDs and almost all. I did do the second one, so it's one or the other, so I got that. And then B... how do you interpret this? So I did get the or. But then... I think that means I only get 1 mark because I did the second part of this or, but not the first. So either you do this with working or you just state the link. I stated the link because come on, it's clear enough. All right, so I get 1 mark, I think. Fine. Okay, 14A. 5005, yep. Increasing trend. Yep, that's what I said, basically. Clothing imports appear to peak in summer. Did I get the season right? Most imports in the summer, autumn. Yes. Yeah. I guess I got the season right then. I wasn't sure. I don't even... It's a very businessy term. It's not a term I use personally. I just say the season. I don't like business terms. 4845. 4845. What? Oh no. Okay, so I got the wrong answer. What did I do wrong? So minus 40, minus 150 over 2 is minus 190 over 2 is minus 95. So I got M1. Oh yeah, because I didn't know what this even means, this mean seasonal variation. So I didn't know what to do with the minus 95. So what did they do with it? So I got M1. And then you... So apparently... Mean seasonal variation. I don't understand. Okay, but I only got 1 mark here. I don't understand this stuff. Mean seasonal variation. I assume the seasonal variation is roughly constant year to year. Yeah, that's basically what I said, yeah. Alright, 44.1. Yep. So this is 5 marks, come on. Why did I write 45.4 there instead of 45.5? But if I... No, but I got the right... Why did I write that? And I didn't calculate it using that anyway, but I think... Oh, but they say or, so you get the mark. It actually says any standardized score. So if you got any of these right, you get that mark, flat mark. Okay, I got all the standardized scores right. Let's see, minus 0.75, minus 0.5, minus 0.67, minus 0.7. Yes, okay, I got these 2 marks. Even though I made a mistake in the calculation, it doesn't matter. All right, Kim swam better in race 1. No, damn it. The score is... You want a low score, not a high score. Because the score is the time it takes you to... Oh, I didn't even think about that. You always think of score as being a good thing. Positive thing. So I got the opposite. Hang on, so I got the first 2 marks, and now what? Oh no, I'm... They don't have an option for what I did. I just thought score was a good thing. It's not a bad thing. I mean, I was clearly along the right lines. I just got it the opposite way around. So I definitely got... No, I got 3 marks so far, because that's 3 marks. M1 and A2 make 3 marks. So do I get any partial marks for these? No, it doesn't give you any option here. So I think the answer is no. So I think I got 3 out of 5. Well, it's the bulk of it, but disappointing. Alright, I'm actually doing worse than I thought I was going to do. It's unfortunate. Okay, 16. A. Hypothesis should be... Yeah. Allows us to estimate percentile values. Oh. The data is discrete. Yeah, that makes sense, I guess. Okay then, didn't get that. Oh man, I'm losing a lot of marks. Work out the percentage, 32%. Yeah. 76, yep. Okay, so I got the range, which is 4, right? I'm glad I redid this question here. What is this? Minus 1.5 times there. Okay, that's the thing I don't know about. So apparently 1.5 is the magic number here. I didn't know about this. If you're outside of 1.5 of the IQR, from the lower quartile, then that's considered an outlier. That's just a thing in GCSE. I didn't know about that. All right, so I got 1 mark. I didn't get the next one. But I did get a suitable conclusion, though. Hang on. No, did I? What do I get here? It's 3 marks. I got 1 so far. Okay, so this thing about the median doesn't matter. Falls more than 1 IQR below. So I'm sort of along the right lines, but I needed to say 1.5 apparently. But I think the conclusion kind of follows from my value that I used, so... There we go. There, 1.5. My 1.5 was essentially 1. So I get the A1 if I'm allowing my 1.5. Okay. I think 2 marks then. Okay. So that's news to me. 1.5 is the magic number. 4, 9, 16, 27, 35, 41, 44, 48, 50. And it looks like that. Perfect. I even put a cross for the outlier. I didn't even know you have to do that. Okay. Okay, H. Okay, reduction overall in strokes in round 2. Yes, I said that. Less varied, more consistent. Yeah, I said that. Okay then. So you needed to basically talk about reduction, but for the other mark, you had to make a comment on spread. Okay. Familiar with the course? Yes. Yes, 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 yes. I'm not happy with that, but okay, let's see what I got. So... I lost 11 marks? Most of those marks I lost because I just didn't know these weird GCSE statistics terms, and then maybe 1 or 2 of those marks I lost just by a stupid calculation error. So overall, I got 69. All right, so what is the pass mark for grade 9? I mean, we still need to do paper 2, but I'm just curious as to what we're aiming for. So let's see. Okay, it's GCSE statistics grade boundaries 2020. Well, that's Edexcel. We need AQA. There we go. AQA. My God, there's so many different history courses. Statistics. Higher tier. For grade 9, you need 134. So I'm just over the boundary, but just. So I need to do better in paper 2, or I need to do as good in paper 2. At this rate, I'll get 138, which will be just above a grade 9. Yikes. Oh, that's interesting. So according to this, if you do foundation tier, you're only eligible for grade 5 at best. You can't get 6, 7, 8, 9. Even if you get 160 out of 160, you still only get a grade 5. And the boundary for grade 5 out of the 160 marks is 86. So if you get 50, almost just over 50% of the marks, then you get grade 5. But if you do any better than that, you don't get anything better. I didn't know that's how it works. But it does make it probably easier to get a grade 5, but that's the point of the higher tier. And higher tier, you're also not able to get a grade 2 or grade 1 as long as you get 28 out of 160. If you get lower than that, you probably get an unclassified grade. Interesting stuff. All right, I'm a little disappointed, but it's still in line with my predictions, so it's fine. All right, well, statistics paper 2. I might do it tomorrow, actually, around the same time. Just get this done. It was interesting. I knew they would throw in some terms that are just really, really specific to GCSE that you never really use. When have you ever seen box and whisker plots used in the workplace, in the business workplace? I just see scatter graphs, line graphs, but box and whisker plots? I don't know, maybe.